everyone. We are going to solve problem number 11 in this one video. We have two long wires, and they are oriented so that they are perpendicular to each other, and at their closest they are 20 centimeters apart, as we can see in the figure to the right. The question is, what is the magnitude of the magnetic field at a point midway between them if the top one carries a current of 2 amps and the bottom one carries 3 amps? So we will start off by writing out the information that we have. We know that I top equals 2 amps and the current on the bottom equals 3 amps. So now what we want to know is, how does the magnetic field generated by a wire vary with distance? We have a very basic, simple equation for that. We would say that magnetic field given by B is equal to the constant mu naught, which is known as the permeability of free space. We're talking about for magnetism, multiplied by our current in our wire, I, which we have listed above for each wire, and then divided by 2 pi, another constant you're very familiar with, and then lastly simply multiplied by r, which is your distance from the wire out to whatever arbitrary point you would like to find the magnetic field strength at. They use r because it's radially outward. So for both of these, r would be 10 centimeters. Of course, we don't like centimeters in our class. We use the MKS system, which stands for meters, kilograms, and seconds. So we'll be using meters. So for example, to calculate the magnetic field coming from the top wire, we would simply put in 4 pi times 10 to the minus 7 multiplied by the current in the top wire, 2 amps, divide by 2 pi, and 0.1 meters. This will give you, if you use your calculator correctly, a magnetic field of 4 times 10 to the minus 6 Tesla. Whenever you see something like minus 6, you can say micro, so 4 microtesla. And that's at a distance of 10 centimeters. Okay, so it's a little bit difficult to visualize. Once we calculate the other magnetic field, the magnetic field on the bottom, by the way, will be, if you go through the same procedure, 6 microtesla. That mu is the same symbol used up here, so don't be confused. Mu just means micro, so this is 6 times 10 to the minus 6 Tesla. It's really tricky to visualize once you have these two strengths, because we have some magnetic field strengths, but we're not really sure about the direction, and we would like to put them in as a vector and calculate them. So using your right-hand rule, and we are talking about the one where we have our thumb pointing in the direction of the current flow, and our fingers wrapping around the wire, which will show you the direction that the magnetic field is going. Well, if we look at this top wire, if you grab this and it is pointing at you, then that means that the magnetic field will wrap around the wire in a counterclockwise fashion. That should be a circle. I'm sorry, I'm not an artist. So at this point, we would say that we would have something going to the right. The one on the bottom is going to be a little bit difficult to visualize, but stick your thumb in the direction going right, and then wrap your fingers around this. They will be going away from us, so we would draw an X on the bottom for our magnetic field, and then it'll be a dot because our fingers will be coming towards us. If we wanted to maybe attempt a 3D drawing, it would look something like this, wrapping around, where our arrows will somewhat give us an idea of how the magnetic field wraps around. So in this case, right at this point, well, we can't draw an arrow to the right or to the left. It's just going to be coming out at us. So maybe from an orthogonal perspective, we would have B from the bottom one, which is slightly larger than B from the top. So then we'd have another one kind of looking like this, about 2/3 the length, BT. For this, we want to take our values and find the hypotenuse, which will be given here. And it might be a little bit of a flashback, but what you're going to use is Pythagoras' theorem. So a squared plus b squared equals c squared. So in this case, we take 4 microtesla, square it, add it to 6 microtesla, and square that, then take the square root of the whole thing, and this should give you a net magnetic field of 7.2 times 10 to the minus 6 Tesla.